So let's start with OpenAge.
Yes, hello. We are the development team of OpenAge, which is a free re-implementation of Age of Empires that probably many of you know. We require the original assets and do this mainly because of unlimited possibilities and writing awesome mods for that thing. We base that on mainly C++ and Python 3. For the user interface, we chose Qt. This year, we have three main advancements, which is a web interface for our continuous integration system. The Neon configuration framework was my master's thesis. And we have an event-based game engine concept for the simulation calculation.
Okay, so let's start with the continuous integration system. Last year we held a whole talk about it. This year, just a quick update. We have now actually included a web interface. It looks about like this. On the right you can see the output, the real-time terminal output, and on the left you can see the individual build steps with status and so on.
Neon is our configuration system for the game behavior, which is a plain text format, a bit like YAML or JSON, which contains key value pairs that can update values through inheritance, and where modifications are done through patches. And this is optimized for mod creation because patches can also patch patches. So that means you can modify everything in the game with a single system. So in this case, the generic unit is specialized to be a villager, and the super villager is an even more specialized villager, so that when you evaluate the health points, it's 35 for the super villager. The modifications are done through patches. In this example, when you discover the Loom technology, the villagers are stronger and then have 35 HP. But Neon can do much more because it allows patch transaction and history and has many more data types and allows mod combinations through overlays.
The new game engine concept is tickless and event-driven. It will only recalculate events or the future if necessary. It will store the whole history and future of the game. And the rendering is actually only doing a snapshot of the engine and then drawing it to the screen. There are different types of interpolations. You can have a continuous line. You can have discrete steps for arbitrary types. You have maps and queues that can be accessed over time. Then, for example, the unit description in C++ is you have a discrete curve of hit points and a continuous curve of a position, then you insert a value at a specific time into this curve, and in the end you can access it at any value in between. And for example, you can predict that the arrow will hit the villager in roughly 5 seconds, then the hit points will go down to 0, so the villager is dead and stops building the building he's working on, and that's an event that's going to be triggered and issues a recalculation of this event. Like the building finished event will be predicted into the future, and if there's no villager working on it anymore, it will be dropped. And for example, an event will be the building construction finished, the building is getting damaged, or a unit starts together, and all the interaction in the game is described using these events and gets registered onto the buildings and onto the internal structures of the game. Like the building 42 triggers the event, its construction has finished at a certain time when it's finished.
So our next steps for the project are the integration of those two systems to implement actual gameplay features that most of you have been missing for a few years now. We also need a cool pathfinder based on flow fields, and we also need a new renderer because the current one is really crappy, but we have a great guy already starting to work on that. So thank you for listening. You can meet us at the StuStaNet assembly, and we hope to talk to some of our community contributors, that we have a lot of them. Thank you for your attention.
Thank you.